Hello everyone, my name is Asdeep Ramanik and today I am going to present my B.Tech project on aircraft schedule recovery problem. This project is supervised by Professor Gautam Sen. Here comes the problem statement. The aircraft schedule recovery problem involves minimizing the total recovery costs and passenger inconvenience when flight schedules are disrupted. While adhering to safety and regulatory requirements, which consists of notice to airmen, night curfew, airport compatibility constraints, etc. The aim of this project is to develop efficient recovery strategies for restoring schedules quickly and effectively by incorporating innovative methods. Now the question is that what is the significance of schedule recovery in aviation operations? So schedule recovery plays a crucial role in ensuring operational efficiency in the aviation industry by addressing delays and cancellations which allow airlines to optimize their resources, reduce operational costs, and improve passenger satisfaction. So this project mainly highlights the importance of schedule recovery for minimizing disruptions and maximizing airline efficiency. Now moving to the next slide, which is literature review. So through an extensive review of this literature, I have identified key methods and challenges associated with the aircraft schedule recovery problem. One of the main approaches discussed is the enhanced column generation scheme, which addresses flight clubbing, maintenance constraints, and operational disruptions. This method has been shown to significantly reduce recovery costs by up to 31.6% while managing multiple disruptions and ensuring aircraft airport compatibility. Also, I have briefly gone through several other relevant studies which have contributed to our understanding of aircraft and passenger recovery. These include mixed integer programming models, column and row generation methods, and heuristic approaches to aircraft routing and maintenance. Each of these studies addresses different aspects of the recovery process, such as aircraft reassignment, clubbing of aircrafts, and optimizing flight schedules. So, moving to the next slide, that is schedule recovery solutions. So, there are mainly three approaches solving the aircraft schedule recovery problem. Those approaches are column generation, local search heuristic, and clubbing of flights. So let me explain one by one. First comes to column generation. This involves rescheduling flights by solving subproblems iteratively, focusing on minimizing delays and cancellations while considering operational constraints. Now let me change the slide. Next come local search heuristic. This technique optimizes flight swaps between affected and unaffected aircrafts to reduce unnecessary disruptions. And the last one is clubbing of flights, a novel approach where flights with the same origin and destination are combined to larger aircraft, which significantly reduces recovery costs. Now, moving to the next slide, the column generation algorithm. Firstly, we formulate the master problem by relaxing the integrity constraint. We then initialize the master problem with an initial set of columns. Initial set of columns can be found using intuitive initial solution and local search heuristic algorithm, as mentioned in the literature. Next, we solve the subproblem for each aircraft using a route finder algorithm. And the route finder algorithm is basically finding new routes corresponding to most negative reduced cost. So in this way, we iteratively generate new routes to improve the solution and resolve the master problem. And the process continues until no further improvement can be made. And finally, when all the routes has non-negative reduced cost, we stop the iteration and solve the restricted master problem by considering the integrity constraint which we relaxed earlier. Now it's time for mathematical modeling. So here is the LP formulation of the master problem, which is crucial for solving the aircraft schedule recovery problem. And the model helps us to define the constraints and objectives mathematically to optimize the solution. So these are the notations which are used to formulate the LP. Here XCL and YF are basically Boolean decision variables. Now let me change the slide. So here in the next slide, the actual formulation is basically our main objective is to minimize the total recovery cost, which subject to total five constraints. So the first three constraints are mainly flight cover constraint. Next one signifies the aircraft can be assigned to at most one group only, and the third one is aircraft balance constraint. And finally, the last two are basically Boolean integrity constraints. Now, finally, my current implementation goals focuses on programming the following solution using IBM iLox Simplex OPL, and I aim to initialize the RMP effectively using intuitive initial solution and local start heuristic, and also use of root finder algorithm to solve the subproblem efficiently. Thank you.